For NF1, understanding equivalent fractions. So today we're going to look at how to identify equivalent fractions and create equivalent fractions, whether we are simplifying them or just trying to make equivalent fractions using multiplication or division. We're going to look at visual representations, and then we're also going to look at the math behind it. All right, so the first thing we need to look at are our definitions. So here, again, I have the word, and then you can just draw in the example. So we know a fraction is in the form a over b. Proper fractions have a smaller numerator than denominator. However, you can create equivalent fractions for improper fractions. That is absolutely possible. We're just going to focus on proper fractions. The numerator is the number that is on top. It tells you how many parts you have out of your whole. The denominator is the bottom number, and it tells you how many pieces you need to make a whole group. So for example here, 3/7. I have 3 pieces and I need 7 to make a full group. Now equivalent fractions are fractions that have different numbers but show the same value. I really like to explain equivalent fractions by comparing it to, like, if you're talking about money. So if you have a quarter, we know a quarter is worth 25 cents. Now I can also have a dime, which is worth 10, another dime, which is worth 10, and a nickel, which is worth 5. Even though these are represented in different ways, they are both equal to 25 cents. They are equivalent amounts of money. So even though their numbers look different, their value is the same. So really what it comes down to is different numbers, same value. All right. Now the big thing with equivalent fractions is remembering that special rule when it comes to math. What you do to one, you have to do to the other. So with fractions, we phrase that as what I do to the bottom, I have to do to the top, or what I do to the top, I have to do to the bottom. Okay? And the thing is, you can only use specific operations for this, but we'll get into that in a minute. Okay, so looking at this, how does it work? What's happening when we are creating equivalent fractions? Well, we are going to look at this by using we're going to use fraction tiles here. But in order to do that, I have to actually come out of the slideshow mode. So I'm going to do that. All right. So coming out of slideshow mode. So here, if I have 1/2. So if I have 1/2, I should be able to break it into smaller pieces that will be equivalent to the 1/2. So let's take a look at 1/4. I know that I can fit 2. So here's 1, and if I copy and paste, okay, I can fit 2 of these 1/4, and it'll be the same size as 1/2. Let's see if that works for thirds. So if I do that for thirds, so here's 1/3. Right, and if I make a second one, okay, and if you look at that, we notice it doesn't work. 2/3 is actually going to be bigger than the 1/2. Now that doesn't mean that there isn't an equivalent fraction for halves and thirds. It's just it's not a nice number that we want to work with. Okay, so what we're looking at is we're saying, okay, well, if I take these pieces and cut them into smaller pieces, how many do I need for them to be the same size? All right, so let's go ahead and go back here and take a look again. So thirds didn't work. Let's look at fifths. All right, so if I do fifths, actually let me put those fourths back. There we go. All right, if I do 2/5, that's not enough. But if I do 3/5, it's too much. So fifths aren't going to be something that's going to work with halves in a nice way. So we'll go ahead and we'll get rid of those. Let's take a look at sixths and see if we notice anything here. So I have 1/6. If I copy it and make 2, still too small. But if I make 3, it works. So 3 of these sixths is the same thing as one of these halves. It's also the same thing as 2/4. So imagine it this way. Imagine you're taking this 1/2 and you're cutting it into, like here we cut it into 3 pieces. When we cut it into 3 pieces, it turned those into 1/6. Now think about it. It kind of makes sense. We know that 1 out of 2 means I have half of a group. I know that 2 out of 4 means I have half of a group. I know that 3 out of 6 means I have half of a group, right? So looking at these numbers, looking at the logic behind it, or just kind of looking at what we end up with, you're looking at half in terms of, well, what makes half of a number? And when you look at odd numbers, so 5, well, half of 5 is going to be 2.5. So it's doable, but it's not something nice that we want to work with. So it's not going to have a nice equivalent fraction to 1/2. It's going to end up having a denominator, or what we call a complex fraction. Here, though, our denominator is 8. And I know that 8 is an even number, and I know that half of 8 is 4. So let's take a look at this and see if I make 4 of these. Oops, I probably shouldn't resize it. That's going to change whether or not it fits. All right. Now, granted, look at this. We're in a world of technology and trying to make these perfect. I did my best. There we go. I had to move it a little bit. So 4/8 is also going to be the same thing as 1/2. So they're the same amount. It's just we cut them into smaller pieces. Think of it like a pizza. If I have a whole pizza and then I cut it into 2 pieces, that means I cut it into halves. Then if I take that half and cut it into 2 more pieces, it means I cut it into 4ths. All right. So 2/4 of the pizza is the same thing as saying I have half of the pizza. Let's go ahead and try some of these together. All right, so I gave you a space you're going to have to draw. Unless you're on your digital notes, then you can use the tiles that are provided for you. So let's take a look at 2/3. So if I have 2 of these, now remember they have to be the same size, so each of the thirds has to be the same size, right? I can look at, okay, well, let's look at multiples of 3. So 3 and then 3 times 2 is 6. So let's try 6ths. Well, if I take this 3 and I cut it in half, that's about the size of 1/6. So I can fit 2 of those. So I can fit 2/6 inside of 1/3. So if I have 2/3, it would make sense that I would have 4/6 because there's 2 of these inside of 1 of these. Right? So what we're saying here is we're saying that if I have 2/3, it's the same thing as somebody else saying, oh yeah, well I have 4/6, so I have more. No, you don't have more. You have the exact same amount. Yours are just cut into smaller pieces and mine are larger. Right? So if you and your friend are arguing over who has more pizza and he says, well, I ate 2/3, and the other says, well, I ate 4/6, you ate the same amount of pizza. It's just you ate more slices because your slices were smaller. Okay? So keeping in mind, every time we do this, our tiles have to end up the same size. If they didn't end up the same size, they're not equivalent. So for example, a lot of times I have students that like to tell me that 1/2 is the same thing as 1/4 because they multiplied 2 by 2 and got 4. But it's not the same. They forgot that what they do to the denominator, they have to do to the numerator. So they have to make sure, well, if I cut this piece in half, they became 4ths. And now I have to have 2 of them here to still be the same thing as the 1/2. Okay? So if you take a look at all of these fraction tiles, like 1/4, 1/5, 1/2, you'll notice even though each of them, even though each of them is 1 out of something, the bigger the denominator gets, the smaller the piece gets. Okay, so even though each numerator is worth 1, because the denominator is larger, it means your piece is getting smaller. Again, I'm going to take it right back to pizza. Every time you cut your pizza into more slices, your slices get smaller. You get more of them, but the size gets smaller. So here I'm getting more tiles, but the tiles are getting smaller. Which makes sense then, because if you have smaller tiles, you should be able to fit some of the smaller tiles into a larger tile. So let's take a look at what's happening mathematically when we do this. And I'm going to go back into our presentation here so it looks a little bit nicer. Okay, so what's happening mathematically? Well, we said 1/2 is the same thing as 4/8, because when I cut it up into 4 pieces, and you have to remember, you have to look at, okay, well, what's happening to the whole when I do that? So when I cut this half up into 4 pieces, there's this invisible other half that also got cut into 4 pieces, which means altogether so there's 4 more here and there's 4 here, so they're worth 8. All right, so I took that 1/2 and I took the half, so I took the 2 and I multiplied it, or I cut it into 4 pieces. So when I did that, this 1 also got cut into 4 pieces. So when I had 1/2, I had 4 out of 8. Okay, because what I do to one, I have to do to the other. And even though we can't see this, so this is the invisible friend over here, okay, I have to, whatever I do to one of my fractions is happening to the whole thing. Okay, it's happening to not only that fraction, but to the rest of that whole group. So when I took my half and cut it into 4 pieces, when I took that 1 piece and sliced it into 4 pieces, I also had to do it to the second piece, because that second piece creates a full group. All right, so let's go ahead and try this. So here I went from 2 to 6. Now, the only way that you can do equivalent fractions is with multiplication and division, because let's look at it this way. When I took this 1 and cut it into 4, if I did 1 plus 4, that would give me 5. And then if I did 2 plus 4, that would give me 6. So looking at it, there's my fraction bar. Would that give me an equivalent fraction? Would 5/6 be the same thing as 1/2? Well, we know 5 out of 6 is more than half. So we know 5/6 is not the same thing as saying 1/2. They are not equivalent. When you cut things into pieces, you are multiplying them. Okay, so in the world of fractions, when you're chopping up your fractions into smaller fractions, you're multiplying them. So I took this 1 and I made it into 4 times as many pieces. So here I'm taking the 2 and I cut it into, now I have 6 pieces. Okay, so I have 3 times as many pieces as I did before. So since 5 is what I have in my whole group, now I have to have 3 times as many pieces in my whole group, so it has to be 15. So my equivalent fraction here would be 6/15. Here I took 8 and I cut it into 5 times as many pieces. I didn't cut it into 5 pieces. I cut it into 5 times as many pieces. And again, even though this is improper, I still would have to take those 3 pieces and cut them into 5 times as many pieces, and I would get 15. Looking at this, if I have 8/3, I know that that means that I have 2 and 2/3. Well, if I have 40/15, let's look and see how that works. So 15 and 40. 15 goes into 40 twice, and that's 30 pieces that I use, and I have 10 left. So that's 2 remainder 10. So that's 2 full groups with 10 pieces out of 15 left over. Okay, and as we're going to look at here, I can take both of these and show that I can divide both of them by 5, and I would get 2 and 2/3. So it is true that these two are equivalent. Here I went from, now I started with the denominator this time, and that's okay. So I went from 4 to 28. So I have 7 times as many pieces. So my numerator has to turn into 7 times as many pieces. So that means I went from having 1 piece to having 7. As long as you follow that golden rule of what I do to the bottom, I have to do to the top, you will be good to go. All right. So when it comes to simplifying fractions, when you're simplifying fractions, you're making it smaller. You're making them simpler to work with. So you're making your numbers smaller. You're not making the value smaller. You're making your numbers smaller. And we know that in order to make numbers smaller, we use subtraction or division. Since we're working with equivalent fractions, we have to use division, no subtraction. So what I can do here, I can actually use the greatest common factor to make equivalent fractions to simplify them, but we're going to do that in our next step. Here, I can find a common factor. So 6 and 12 can both be divided by what number? They both can be divided by 2. So I'm going to, just like I did before, and I will actually set it up in the same format as I did before. There we go. So now I'm dividing by 2, and what I do to the bottom is I have to divide by 2. Okay, so that tells me, so 6 divided by 2 will give me 3, and 12 divided by 2 will give me 6. Let's see if that makes sense. I know that 6 out of 12 is half of a group. Is 3 out of 6 half of a group? The answer is yes, it is. So since they are both the same thing as 1/2, that means they're both equivalent. Now, could I make that fraction smaller? I could, but we're going to talk about that next. 2 and 8. 2 and 8 have a common factor of 2, so they both can be divided by 2. Now, when I set this up, what I like to do is I like to show that I have to divide. I know I have to divide by some type of fraction. Okay? And I'm going to divide by 2, but what I do to the top, I have to do to the bottom. So I show here that I'm dividing by 2 over 2. And I know 2 divided by 2 is 1, and 8 divided by 2 is 4. Now you might notice that 2 divided by 2 is equal to 1. And we know that anytime we multiply or divide by 1, our value doesn't change. So yes, I am dividing by 2, but I'm doing that to the top and to the bottom. So since I'm doing that to the top and to the bottom, and that makes this, so this here is equivalent to a whole number, that means I'm not changing the value. And if that doesn't click just yet, that's okay. In time, it'll make a little more sense. All right, if you want to try the next one, and come back and check your answer, you are more than welcome to. We're actually going to divide by 4 this time. Okay, so I can take both of these and I can divide by 4. What I do to the bottom, I have to do to the top. So these two numbers that I'm dividing by have to be the same. Right? And 12 divided by 4 is 3. And 36 divided by 4 is 9. Could I have come up with different answers here? Absolutely. I could have divided by 2. Okay, so I could have taken 12/36 and divided them both by 2 over 2. And that would have given me 6/18. So what that means is 12/36, 3/9, and 6/18 are all equivalent. The biggest thing here is remembering you can only use multiplication or division. and that you have to do the same thing to the bottom and to the top. All right, so in here, I want to remind you that you can use the greatest common factor to simplify your fractions. So here, let's look at 16 and 24. 16 can be divided by 1, 2, 4, 8, and 16. 24 can be divided by 1. Well, and we don't even have to list these. It can't be divided by 16, but it can be divided by 8. So the GCF of these two numbers is 8. So then to simplify it, I would have to divide both of these by 8. Right? And you are going to do that work to get your answer. Here, the GCF of 8 and 20. So again, list the factors of the smallest number. So 1, 2, 4, and 8. 20 isn't divisible by 8, but it is divisible by 4. So the GCF is 4. So you're going to set it up and divide both of them by 4. Right? And then you have these two problems here. So you are going to figure out how did you go from one to the other. And so you're going to find your missing number. Oops, went too far. And then you are also going to create two equivalent fractions for each of the given fractions. So you're going to create two equivalent fractions for 4/8. And you're going to create two equivalent fractions for 3/7. Right? And when you come back to class, we'll go over the problems and check your answers.